Hello students, welcome to Time Classes. In this session, we are going to discuss about hybridization. This topic is from Chemical Bonding class 11th. Before going to the topic, I would like to introduce our YouTube channel, Time for IITJEE NEET. Please like, share and subscribe our YouTube channel. So what is hybridization? It is defined as the intermixing of atomic orbitals of slightly different energy and shape so as to redistribute their energies, resulting in the formation of new set of orbitals of identical shape and similar energy. It is a process of intermixing of atomic orbitals, and these atomic orbitals are from the same atom, but they differ slightly in their energies and shape. After mixing, they redistribute into equal number of new set of identical orbitals, and that orbitals are called hybrid orbitals. That are called the hybrid orbitals. Suppose if we take carbon, configuration is 1s2, 2s2, 2p, x1, 2p, y1 and 2p, z0. In its ground state, carbon can form 2 bonds only. So in order to form 4 bonds around it, because carbon is tetravalent element, so one electron has to be excited from its 2s orbital to 2p orbital. So the excited state electron configuration of carbon is 1s2, 2s1, 2p, x1, 2p, y1, 2p, z1. So in the excited state, carbon undergoes some intermixing process. For example, one s orbital, if it is intermixing with one p orbital, so this is called sp hybridization, and it is forming two hybrid orbitals. If one s orbital and two p orbitals are mixing, that is 2s, 2s, 2px and 2py and 2py, then it forming the sp3, sp2 hybridization, and it forms 3 sp2 hybrid orbitals. If 4 orbitals are intermixing, that is 1 s orbital and 3 p orbitals, we get the 4 hybrid orbitals, and the hybridization is called the sp3. Based upon the number of orbitals involved in the process and the type of orbitals involved in the intermixing process, we have the different types of hybridization. One is sp, sp2, sp3, sp3d, sp3d2 and sp3d3. In case of sp, it is the intermixing of one s orbital with one p orbital, and it is forming the two hybrid orbitals. 1 plus 1 2, 1 plus 1 2, and the name of hybridization is sp, s power of 1, p power of 1. So this is sp. In case of sp2, it is the intermixing of one s orbital with two p orbitals and s power of 1, p power of 2. So it is called the sp2 hybridization, and this leads to the geometry of trigonal planar. In case of sp, it is a linear geometry. Similarly, in case of sp3, it is an intermixing of one s orbital with the 3 p orbitals, and it is forming the 4 hybrid orbitals, and the geometry is tetrahedral. These hybrid orbitals, they orient towards the 4 corners of the regular tetrahedron, and it is forming the sp3, it is forming the tetrahedral geometry. In case of sp3d hybridization, it is 1 s orbital with 3 p orbitals and 1 d orbital. Here the d orbital is dz², and it is forming 5 hybrid orbitals, and this leads to the geometry of trigonal bipyramidal in the molecule. And sp3d2, here it is 1 s orbital is intermixing with 3 p orbitals and 2 d orbitals, resulting in the formation of the 6 identical orbitals called the 6 hybrid orbitals, and this leads to the geometry of octahedron. In case of sp3d3, it is the intermixing of 1 s orbital with the 3 p orbitals and 3 d orbitals, and it is forming the 7 hybrid orbitals, and the geometry of these 7 hybrid orbitals is a pentagonal bipyramidal. So these are the different types of hybridization and the number of hybrid orbitals based upon the orbitals involved in the process, number and type of orbitals involved in the process. The linear geometry example is BeCl2. Example on carbon dioxide, we can write the carbon dioxide. In case of triangular planar, the examples are BF3 and BCl3. Similarly, for the tetrahedral geometry, examples CH4 and SiCl4, etc. For triangular bipyramidal, the examples are PCl5, and for octahedral it is SF6, and for pentagonal bipyramidal the example is IF7. So these are the molecules having the regular geometry of linear, triangular planar, tetrahedral, trigonal bipyramidal, octahedral and pentagonal bipyramidal by considering no lone pair of electrons on the central atom. There is no lone pair of electrons on the central atom. These are only the bonded electron pairs. Prediction of hybridization. How to identify the hybridization of the central atom? So this can be done by the application of the following equation or the formula. H is equal to 1 by 2 V plus M minus C plus A. By using this formula, one can find the type of hybridization on the central atom in the molecule. Here the H is the number of orbitals involved in the hybridization process. V is the number of valence electrons on the central atom. M is the number of monovalent atoms. And in case of number of monovalent atoms, we have the 5 elements. One is a hydrogen, fluorine, chlorine, bromine, and iodine. C is the magnitude of the cation, and A is the magnitude of the anion. From the value of H, the type of hybridization can be predicted. If the H value is 2, it is sp hybridization. If the H value is 3, it is sp2. If it is 4, it is sp3. If it is 5, it is sp3d. And if it is 6, it is sp3d2. And for 7, it is sp3d3 hybridization. For example, if we take carbon dioxide. Here the central atom is carbon and H value is equal to 1 by 2. And central atom carbon has the 4 valence electrons, 4. Monovalent atoms has 0. There is no cation and there is no anion. So this is equal to 4 by 2. 4 by 2 means 2. 2 means it is sp hybridization. And it is a linear geometry, and we write structure of this carbon dioxide is like this. This carbon is having the sp hybridization. Similarly, if you take one more example of ammonium ion NH4 plus. Here the central atom is nitrogen and H value is equal to 1 by 2, and nitrogen valence electrons are 5, monovalent atoms are 4, and one positive ion is there, so magnitude is 1. So this is equal to 8 by 2 is equal to 4. 4 means it is sp3 hybridization. So like this you can predict the type of hybridization based on the formula, that is H is equal to 1 by 2 V plus M minus C plus A. There are some other ways of finding the hybridization. If we know the structure of the molecules, H is equal to sigma plus number of lone pair of electrons. Let us go for one example, that is a xenon difluoride. In the xenon difluoride, so the central atom is xenon. It has 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. 2 fluorine atoms are present, and fluorine atoms are the monovalent, and each fluorine is forming a single bond with the xenon. So it is forming the two single bonds. So all single bonds are the sigma bonds. This is sigma and this is the sigma bond. And the remaining 6 electrons, they are forming the 3 lone pairs. So on xenon, we have 2 sigma bonds plus 3 lone pairs. So we have to add these numbers. So 2 plus 3 is equal to 5. So this is a value of H. So it is sp3d hybridization. In organic compounds, we can also use this formula. For example, Suppose if we take the CH3, single bond CH, double bond CH, and single bond C, triple bond CH. In this case, the type of hybridization on each carbon. For this example, are the organic compounds which contain more than one carbon atom as a central atom. So we cannot apply the first formula for finding the hybridization. Here we can apply this formula. So let us check for this carbon how to find this. This carbon is surrounded by all the single bonds. All single bonds are the sigma bonds. Here the 4 sigma bonds. For this carbon we have 1, 2 and 3. In a multiple covalent bond, 1 is a sigma, remaining are the pi bonds. So this carbon is having 3 sigma bonds. Similarly, this carbon is having 1 sigma here, 1 sigma and 1 sigma. 3 sigma bonds. For this carbon also we have 1 sigma here 1 sigma, 2 sigma bonds. For this carbon it is a 2 sigma bonds. 4 sigma bond means the value of H is equal to 4. H is equal to 4, this is 3, this is 2, this is 3 and this is 2 and this is 2. 4 means it is sp3 hybridization. 3 means sp2. Here also it is sp2 and this is sp and this is sp. So by using this formula, H is equal to number of sigma bond plus number of lone pairs. If carbon is bonded with all the 4 single bonds like this, it is sp3. All single bonds means sp3. If it has a double bond and 2 single bonds, then it is sp2. Or if we have this kind of structure, if it is having a triple bond and 1 single bond, it is sp hybridization. If it is having 2 double bonds around it, then this is also sp. I hope you understood all the 3 ways of finding the hybridization. This is almost similar to this only, but here we are not talking about the lone pair of electrons. Only by seeing the structure you can find the type of hybridization by identifying the bonds around the carbon. 4 single bonds sp3, 1 double bond, 2 single bonds sp2, 1 triple bond, 1 single bond is sp. Both of the bond on both sides, if the carbon is having 2 double bonds, it is a sp hybridization. Let us consider some questions based upon the hybridization. The hybridization of sulfur and sulfate ion is, sulfate is SO4 2 minus. So we can apply the formula H is equal to 1 by 2. Valence electrons on sulfur is equal to 6 because it is a 6th A group element, or group 16. Number of monovalent atoms are 0 and there is no cation, and here it is an anion and the charge is 2 minus, magnitude is 2. So this is equal to 4. 4 means it is sp3 hybridization. So the answer is option A. The next question is, find the hybridization of central carbon atom in the following examples. In the first example, we can apply any formula from the 3 cases. Here by just seeing the molecule you can tell the hybridization. So this carbon is having the 2 double bonds around it. Directly you can write the sp hybridization. Similarly, this carbon is also having the 2 double bonds around it. So sp. This carbon is also having the double bonds. So 2 double bonds, it is also sp. If we want to apply the formula, also you can find on the first carbon number of sigma bonds, oxygen, double bond, C, double bond, C, double bond, C, double bond, oxygen. If we want to find the number of sigma bonds, this is 1 sigma and this is 1 sigma. So it is 2 sigma bonds, 2 sigma bonds. This carbon is also surrounded by the 2 sigma bonds. This carbon is also surrounded by 2 sigma bonds or bonded with the 2 sigma bonds. 2 sigma bonds means H value is 2. Here H value is 2. Here also H value is 2. H value 2 means all the carbons are undergoing sp hybridization. Second example, we have the 2 bonds with CH2, double bond C, H and H. Now on this carbon we have the arrangement like this, that is sp2 directly connect. On this carbon we have the 2 double bonds, so this is sp, and on the third carbon we have the 2 single bonds and 1 double bond, so it is sp2. Or we can also find in terms of sigma bonds. This is 1 sigma, 1 sigma, 1 sigma. So this carbon is having the 3 sigma bonds around it. This carbon is having 1 sigma here and 1 sigma here. So 2 sigma bonds. This carbon is having 1 here, 2 and 3. So 3 sigma bonds. So H value is 3, 2 and 3. This is sp2 and this is sp and this is sp3 hybridization. I hope all of you understood this. So the third example is, similarly you can find CH2 double bond C double bond oxygen. So this carbon is surrounded by the 2 double bonds, so it is sp, and this carbon is having 2 single bonds with the 2 hydrogen atoms and a double bond, so this is sp2 hybridization. I hope all of you understood this. The next question is, find the number of molecules or ions that show linear geometry from the following. So linear geometry means either it should be having the sp hybridization or sp³d hybridization, and in sp³d hybridization the condition is it should have the 3 lone pair of electrons and 2 bonds, 2 sigma bonds. We can take the Lewis dot structure like this. So the central oxygen is having the sp2 hybridization, 1 sigma here, 1 sigma and lone pair of electrons, so it is sp2 and it is a bent geometry. From the Lewis structure also it is bent geometry. In case of NO2 plus, nitrogen having the 5 electrons, 1, 2, 3, 4, 5, and oxygen is 1, 2, 3, 4, 5, 6. This oxygen also having the 6 electrons like this. So they are forming the double bonds with the central nitrogen atom, and this electron is lost by the nitrogen. That's why you got the positive charge. So the type of hybridization is, on this nitrogen, the type of hybridization, this is 1 sigma, 1 sigma. So it is a sp hybridization and it is a linear geometry. So this is linear geometry. SO2, again it is a bent structure like this and with a pair of electron. So this is not linear and the type of hybridization is sp2. BeCl2 is linear because beryllium is a central atom and it is forming sp hybridization, and this is sp and linear. CO2 already explained, C double bond oxygen, and this is also sp hybridization. NO2. So in case of NO2, nitrogen 1, 2, 3, 4, 5, oxygen 1, 2, 3, 4, 5, 6, and another oxygen is like this we can write. So one oxygen is forming a double covalent bond with the nitrogen, and this second oxygen is forming a coordinate covalent bond. So nitrogen is donating a pair of electron, or it is forming a coordinate covalent bond. So 2 electrons you can write like this. To find the hybridization in NO2, we write 1 by 2. Valence electrons on nitrogen is 5. Monovalent atoms are 0. There is no cation, there is no anion, but 1 electron is left out on the nitrogen. So we can add that electron here. So this is equal to 6 by 2 is equal to 3. 3 means sp2. So it is not linear geometry. Next one is F2O. In case of F2O, it is bent structure and oxygen is having 2 sigma bonds and 2 lone pairs of electrons. So it is a bent geometry. And xenon difluoride is having this structure and with 3 lone pairs of electrons. And I3- is also having the linear geometry. And it is having 2 sigma bonds and 3 lone pair of electrons, so it is a linear geometry. I hope you understood the concept of hybridization, and thank you.